Mayank, can you hear me?
Hey, I can hear you now. There was some issues
Okay.
with my mic, with my
Uh,
headphones and mic.
I see.
Hi,
No, I don't see anybody else. I think
Steve was about to
usually
join.
was he? Because I haven't seen. Usually he posts if he is not able to join. So he's pretty good at letting people know. Maybe he has posted something. No, you. Cool. So you got a bronze.
Yeah,
Good.
I was pleasantly surprised by it. I didn't find Steve in the list, in the
He
leaderboard.
No, he's definitely there. He would be silver, probably when he was very close to even a gold.
Yeah, I was thinking about the same thing. All
Yeah,
the
yeah.
participants that we had. If you try to search that on the leaderboard,
Let me see. Um, because he was even until the end. Mm, hmm.
yeah, we talked to him the week before last, and he
Yeah,
alluded
he
to
was
that.
there.
He was there,
He was,
up in the silver levels, but I didn't find him in the leaderboard, so I was wondering.
yeah, maybe he changed his name or something. Or I can see him either. How about? Yeah, I think Raquel is there.
Yeah, Rachel is there. Did he got into a team or something like that?
No, he was still by himself um, until. Oh, it's very weird. I can't seem to um, find him either. Let's see whether he is there in the. No, he's there in the um, current competition. So it's kind of very weird why he's not there. Yeah, I can't see him either. Don't know what's going on with that, but um, why they didn't. That's really weird.
Hmm, that's what I thought.
Yeah. Let's see the leaderboard. Is it? Yeah, because he was even in the upper 20s or something.
Mm-hmm.
So he was definitely in the silver, kind of close to potential gold. So I'm kind of surprised.
If you go on to his profile and try to see the number of silvers that he has got, uh, or if you can, if we can go through the number of competitions that he has had, the winning medals. Can we do that?
I think so. Let me see whether I get to the current competition, because that will definitely have him. Okay. Hmm. Strangely enough, he doesn't show up as one of the completed competitions
Mm-hmm.
in his profile, because he has 3 silvers actually. Oh,
Yeah.
Ubiquant. Oh, that was the prior one. That was 2 years back. Vesuvius also a silver, and I forget where was he. Gold. It was that he got, I guess. Yes. Yeah, there are 3. Anyway, so we're able to. He hasn't usually lets us know. He's pretty good about letting us know about not joining. So I guess he must have had something come up.
Yeah,
And
he
it's kind of
was to visit his son, I think so, in the States, right? In
right.
the
But that's end of the month. That's the
Yeah.
end of this month. So he was saying that he'd have to wrap up before then. So, but so I kind of played around with the divergent models or whatever that you had pointed to, and as I said, I had kind of used my own model for that. I managed to get to about the same as that guy, but with my own model and a combination of my model with a couple of his models, but um, I'm unable to break the 0.31 barrier, and still kind of I was varying the weights and seeing whether it would get me there. But more importantly, or more interestingly, I would say that the more interesting part is what Chris and those guys are at 0.23 and so on, right, in the leaderboard. And I was curious as to what kind of things are they doing that would potentially get them the score that they are seeing, because that is definitely an impressive score,
Mm-hmm.
0.23 type of stuff, right? So I was kind of looking around, poking into what it is that they are doing, and what I found was, um, let's see whether I can find it. Um, Actually, let me look at the code part of it. Give me a minute. know whether it is a code or the discussion, but there is one I think probably in the discussion. Let me check it before I show you that. And there's something I saw. Unfortunately, I thought I'd push here. I think this is the one. About single model. And excuse me. Oh, yeah, this is the one. So let me share. I think this is the one. Let me get to what I.
Hey, Raquel.
Hey, you showed up. What's up, Raquel?
Hey guys.
So you got busy at work?
Yeah, got busy at work and I'm headed to India
Oh,
next week.
Oh,
So
when?
I'll be leaving like next week.
Nice.
So yeah, things are kind of tight.
So where do you live
yeah.
in India?
Bangalore.
Oh, nice.
Yeah. I have a couple of weddings. Friend is getting married. My cousin's getting married. So yeah.
So going for a wedding.
Yeah, I'm going for a wedding. My have a vacation planned since I'm traveling all the way there. So
Yeah.
So how long will you be staying for in India?
I'll be there for around a month or so.
Okay.
That's
So
good. So at least getting a break.
yeah, sort of. Month is a pretty long
So
vacation.
you'll be
Working from there.
working from there or
Yeah,
not?
exactly. Yeah, working from there.
Oh, wow.
So
That's
yeah.
a tough thing. Yeah. So let me show. So sorry, I know you've been kind of distracted, but we kind of were discussing how come Steve doesn't show up in the Optiver competition that just closed, because he was in the silver medal position, pretty close to gold too, but
Right.
we can't find him. And actually, Mayank won a bronze, so that's kind of
Oh, cool. Nice. Yes. That's awesome.
Yeah. Mm-hmm.
That by far was the most frustrating competition for me.
Yeah. But for me, it was really, like I was telling you, I still remember the pain of finding out on the last day, oh man, it just doesn't work, and you know, why and stuff like that, and I couldn't fix it in time and stuff. But anyway, so what was surprising to us was Steve was in silver, but we can't find him in the leaderboard at all. You're there, I'm there, not in the leaderboard. I mean, obviously we are there way back.
Right.
And Steve was like in almost close to a gold position, like, few positions off of gold, but in very comfortably in the silver position. So I don't know why he hasn't suddenly shown up in the medal category and stuff. So that would be interesting if he shows up next week to
what happened. Yeah. Okay.
find out what happened. So here, one of the things I think that
So you're not sharing your screen right now.
Yeah, I know. I wanted to
Okay.
give a preamble before I shared. I want to share. Hang on, let me make sure I'm sharing the right thing.
Did one of his submissions not make it, or I wonder what happened.
Yeah, that's really no. I mean, that's a good question actually, because in fact I thought he had a really smart approach where he was actually not taking in all of the updated data, if I recall correctly. So his was, in fact, a smarter approach than what many people are implementing. Let me know whether I'm sharing. I think I'm sharing the right screen. Can you guys
you're
see
sharing the desktop, I think. The whole desktop.
the HMS?
Yeah.
Oh, so it's not the appropriate screen, right?
Yeah, it wasn't the Chrome window. It was the whole desktop.
Okay, I don't know why it's stuck on. I have two windows and it's kind of like stuck on wanting to share the second one. So I don't know. It hasn't. Normally that hasn't been the problem for me, but I don't know why. Give me a minute while I try to
So
figure this
in the
out.
Optiva competition, we had gone through the book, The Advances in Financial Machine Learning, in which
Yeah.
I think so. Yeah, we had the combinatorial purge cross-validation method that we worked on.
Right.
I think so. You
Yeah.
guys might remember the figure and the Stack Overflow thread that we had going.
Yeah.
So I
Yeah.
learned a lot from that, and maybe that implementation worked. And I don't know what actually worked. I'm still at two ways about that, but I sneaked up in the end.
Nice.
Okay. I think. Well, I don't know. Let me see whether I don't know why my screen is behaving strangely today, but let me see whether you guys can see. Can you see the notebook or
Yeah, the
not?
HMS.
Full brain activity classification.
Yep. Single model best help.
Okay. Right. So this is what I was saying that, so this thread has an interesting, Steve, when we joined, he wasn't able to join last week either. And he and I both and others too kind of converged on this approach, which was giving us pretty good scores up to about, of course, it's still an ensemble of 5 or 10 models, but a single model, not a variation of multiple models. Single model, but still an ensemble of 5 or 10 folds, if you will. But the approach that this guy had taken was to do 2-stage training. The first stage with votes less than a particular number, and then again train that model, if you call that pre-training, then again kind of fine-tune that model with all the data where the votes are greater than, where the number of total votes are greater than 10. And use that, if you will. And then Steve had made some modifications in the, what I would call the augmentation approach and stuff. And that got us on just that single model. I was able to get, and I think Steve was also about 0.34. And then if you combine that with a couple of other models as ensembles, that got me to about 0.31. But what I saw in this thread, and which is what next I wanted to try, of course, there are only 2 weeks left, so I don't know how far I'll be able to get to. But the thing I wanted to point to is, this guy kind of says, okay, here are my best single model results, right? And you can see, some of them are in the point, and I was able to get even lower than 0.36 because with efficiency 2 and this 2-stage approach, I was able to get to 0.34. And you can see most of these are 0.36, 38, and that kind of stuff. But then the fascinating part about it is that if you see, there are several guys here who are saying, like this guy, single model, 4 folds, second stage or whatever, 0.25 leaderboard. It's pretty amazing, right? Because it's,
Yeah.
0.34 and 0.25 are still a ways off. And again, if you see this, with raw EEG, with 1D processing, this guy gets 0.26. With a 2D EEG without Kaggle, meaning he's only converted EEG spectrograms, is 0.27. And then when he ensembles, he gets to 0.24. But none of that. Now, the interesting part is what Chris posted, because he's saying, see, leaderboard 0.25, using all data, both spectrogram and EEG, right? And then the thing that to me was most interesting, because if you go through this thread, at least when I went to it, I think sometime last week, nobody kind of said what it is they're doing, right? Except for Chris, this is what he says. Right. And so I was kind of going to look up, okay, I understand in theory what knowledge distillation does, but I wanted to kind of figure out how I would go about implementing it in this case. But the other thing I wanted to discuss is, because Steve at some point was also trying to figure out, hey, what other things have people done to get the scores they are getting, which is in the 0.2x range? Because none of these ensembles seem to get you below for me, 0.31. I think Steve is at 0.30. But so here is at least a high level things that he has done. So the question I had was regarding 2 of these steps, right? Or at least 2, or maybe even 3 of these steps. Knowledge distillation, okay, I can understand, right? Assuming you figure out what you would do with how you would train the student model. Basically, you get like a large model like ENET V2, and then you get a good result, like let's say 0.34 with a single, and then you try to train a smaller model, maybe a ResNet 18 or something like that, which is quick, and see whether that can get up to the same level as the ENET V2 model. So at least I have some thought about, okay, what I could, I still have to figure out, okay, what are the laws? How do I train? All this kind of stuff. But what I don't understand or would like to discuss is what would pre-train in this case mean or do? How would you pre-train? How would you pseudo-label? Because pseudo-labeling, my recollection is, you do that if you don't have enough labeled data, right? If you have unlabeled data and you want to kind of train on it, then that's my understanding of how pseudo-labeling works. So I was curious. Of course, Steve, I think in the last or 2 call 2 weeks back, had pointed out that there was some of the discussions or whatever, there was somebody posting about additional data. Although the additional data is on like only 10, unlike in EEGs where we are getting 50 nanoseconds. I think the additional data that somebody pointed to only gives 10 nanoseconds, the middle 10, which is still relevant, right? But I don't know whether when he says pseudo labeling, whether he is using that data and then labeling it and then using that data, combining that data with the data that we have already. Because otherwise pseudo labeling doesn't make any sense, right? If you already have labeled data, pseudo labeling doesn't make sense. Or am I missing something? That's what I wanted to kind of discuss, what you guys would think and again, when he says pre-train or fine-tune, what would pre-training entail in this case?
Pseudo labeling, yeah, that's what I've also used pseudo labeling only when you somehow someone provides you with this extra data that don't have labels. and then you kind of use that. So I don't know, I haven't kept track, but if you say that there is some new data,
Yeah, there is. If we can, let me try
probably that
and
is one thing.
search.
Could it do let me try to do a literature search on pseudo labeling and whether that works on the context that you are.
Well, I mean, pseudo labeling, I think is, but let's see whether it is in discussion or.
Pseudo labeling works because I think I've used that both at work and like at a Kaggle competition, and it does boost your thing. But I like in classification stuff where you have a lot more data than, yeah, you basically have labels for it, does surely help in those scenarios.
It doesn't. I wish it had a little better search thing.
Try external data or I don't know, something like that.
It's mostly used in the semi-supervised learning, right? The pseudo labeling part of it.
You can use,
It's a semi-supervised learning technique.
correct,
I was thinking,
but you can use it
uh,
supervised by making it, by getting the labels, right? Once you do the pseudo labeling, then it just becomes supervised learning.
oh, yes, that makes sense. So, we should be able to use it in this context, right?
Yeah, but
Yeah, but it.
I think the link which Srinivas was sharing, it was the person below that had an interesting question, and I don't know if Chris ended up replying to that or not.
Could you share this discussion with us in the chat, Srinivasan?
Where did why does my, hang on, very weird things disappear and appear and stuff for me. Anyway, so I don't know if you guys, yeah, of course the guy below asked the question, but there was no response
Oh, okay.
to that. Um,
Oh, so he's doing it
Also,
on the boards.
I don't know what this means.
Please code when using pseudo label. I careful to maintain different pseudo labels for each board. In some situations, yes.
And then this guy says something. So here it seems, at least what this guy seems to be doing is like I talked about these two stages, right, of based on number of votes. So he seems to say that he takes one model, trains it on data less than, let's say, 10 votes, which means that, there is more uncertainty in the, one would think there would be more uncertainty if you train on the data where the votes are less than 10, because there aren't as many experts weighing in. And you use that to label that model, call it the stage 1 model, to predict the votes or the distribution for the data which has more than 10 votes, right? Then, so you can kind of think, and then, but here's the thing that I'm confused by, right, is you actually have the labels for the greater than 10. So what does pseudo labeling by using the stage 1 to predict stage 2 help you achieve?
Yeah, I've never used pseudo labeling like this. I'm not sure what the
You
approach
see what
is.
I'm saying?
Yeah, I get your question.
So I don't get what this guy is trying to do, because my actual labels will be anyway better than any pseudo label that you generate,
Right.
because you have the actual label. So the reason I would think to use pseudo labeling, at least that's why I said my understanding is that if you don't have labels, then you want to generate as a starting point. And then when you train on that, because you have additional data beyond what is just the label data, then your model gets better.
Yeah.
But I don't see this really helping. But then I don't understand this part either of what Chris is saying.
Yeah,
Maintain different pseudo label for each fold. The only thing that, let's see.
Is he talking about the spectrograms fold with respect to each fold of the particular epoch? Suppose if we take a group K fold of, I think so, 5.
Yeah, that's what he's talking about. But that's what he's talking about. But what I don't get is, like, what is it that, let's say we have additional data, then if he's saying, okay, we have already trained, let's say we have a 5 folds that we have trained, and does he mean, I'm just making this up, I'm trying to interpret what he's saying, does it mean that because it's not a single model, by single model I mean it's not like there is just one, right? We have 5 folds of the model that we then ensemble to get the result. So what he seems to be saying is, when you generate the pseudo label on the new data, generate pseudo labels per fold. That is, take each of the fold 0 to fold 4 models, generate the pseudo labels per each fold, and then average them to get the actual labels. You know what I'm saying? That would make some kind of sense. Do you agree, Raquel?
Yeah, that's what I was just thinking of. Like, sometimes it helps when you have like noisy data, and in our case, that is kind of the case when there are these certain spectrograms where those votes change, right? Like from the beginning part of the those 10 seconds to all the way. I don't know if it's something to do with that.
But that, by the way, that one with all the, weird, I don't know whether you joined us after that, so I'll just mention, all these weird ways that I was trying to get the
Those, yeah,
final,
getting the right windows, yeah.
right? That and drop this and I mean do this and do that and all that.
Mhm.
And then there is the easiest of ways that a guy had done it. I was just like, oh my God. Sometimes
Oh.
it's just like you just mm, you just live and learn, but you think you're so stupid because there is a very simple function in Pandas called drop duplicates, and you can
Oh.
specify whether you want it to drop the first or the last. So we
Uh-huh.
don't need to do any of that fancy stuff that I was trying.
Uh-huh.
You can say drop duplicates, and
Okay. Okay.
based on like if you have EG, then drop duplicates based on the EG, and give me the first when you're dropping, or the first of the dropped, or the last of the dropped.
Right. Okay. Okay. Okay.
Yes, and I was like, oh my God, that's so much simpler than what I was trying to do, than the way I was trying to solve the problem. Anyway, so this aspect, to me, it seemed like these are the things that somehow, let's see whether we can, find the additional data that Steve had pointed to. I don't know where it is, but if I do some search, I'm sure in the discussion or in the code, I'll find pointers to where additional data is, and then kind of with the trained models, do pseudo labeling of that. And based on what Chris is saying, kind of use each fold to do pseudo labeling on, and then average the scores of the folds to get kind of your final labels. And then use that data labeled and combine it with our data to generate the model. But pseudo labeling part, right? But then what is the pre-train, knowledge distillation, and fine tune? What would you pre-train? If by pre-train, does he mean the fact that he's pre-training these fold models on the provided computation data? Is that what is, you see what I'm trying to get at? Like I'm just trying to interpret what his steps are.
Yeah, not sure what that pre-train is.
Right?
I don't know.
Pre-train and then finally also this fine tune. So what would you, so do you fine tune the model on the total data then so that you don't, but how is in that case, my question is, how would it, I mean, the, do you freeze most of the model and just let the head get fine tuned? Is that why he's referring to it as fine tune versus like retraining the whole model on the combined pseudo label plus original data?
I don't know. Pre-train somehow means something to do with just could use like some semi-supervised stuff there, right? Like for example, ResNet that is being trained on uh ImageNet or something over here. So here it'll be use your data and then just kind of do some semi-supervised training. And then after that, you kind of do the fine-tuning using your data. I don't know, the pseudo labeling part is still kind of confusing to me. It makes complete sense if it's the extra data stuff.
Yeah, okay. So extra data will give you the answer to pseudo label.
Yeah.
Knowledge distillation is just bigger,
Yeah.
right?
That's a
But
big.
I am still then lost of to exact meaning of pre-training and fine-tuning.
I think fine-tuning is like what you're saying itself. And pre-training, my guess over here is I can't remember the techniques right now, but for example, what was that where you shit, what is that called?
Yeah, it could be like this,
similar,
right? It
two
could,
similar
but I don't
images.
understand how it is. It could be like this, that, okay, because your model, when you load the weights, from Tim, for example,
Right.
then you're loading the weights of something that has been trained on ImageNet.
Right.
Now, you want to it to be more attuned to, let's say, EEGs,
Right.
spectrograms, not
Right.
spectrograms, right? But my question though is, how is that? Therefore, you want something which is kind of a little more tuned to spectrograms. But how would you do that, which is different than the training that you anyway do on the spectrogram? Would you, for example, as I talk through this, maybe an idea springs to mind, and is it the case that, for example, I'm just making this stuff up, but you take the pre-trained model, train the models that you are, let's say, take an efficient at V2 or whatever, train those models on Kaggle spectrograms,
Right.
okay?
Mm-hmm.
And then take those models
Hmm.
that you have trained on Kaggle spectrogram and assume that that is a pre-train of the models, and then take those models and use them to train on EEG spectrograms.
Yeah, that potentially could work, but I was just saying, like, the general, just using any spectrograms will already be like better than, or at least will be more honed in than just using ImageNet data, right? So I'm guessing some pre-training. I don't understand the details because I'm not in touch completely with this competition right now. But I'm thinking it's like moving away, like you don't need to know what cats and dogs and those kind of things are. So you're moving away from that and kind of training more on what spectrograms, mainly that stuff is, if that makes sense.
Right, and predicting the 6 classes, right? Because that's the
Yeah,
6 classes that you care about.
no, but I'm saying
But what I'm saying is,
not even
the way, sorry, go ahead.
not even like I'm not even saying the 6 classes. I'm just saying you're just showing it what spectrograms are. I'm talking of just some semi-supervised sort of thing, which is the pre-training part over here.
Right, but how would you gauge that it's improving or that it is, actually doing pre-training
But the
in effect,
pre-training,
if you didn't do
if you didn't do
something
what?
like what I was saying?
No, but the improvement part, isn't that just the final model or the final CV or the LB that you're trying to do?
No, but what would you actually do in the pre-training section then?
So let's say you have a bunch of spectrograms.
Right.
You use some semi-supervised learning, which basically, I think I'm guessing here is showing, like, let's say these two spectrograms are similar or have the same votes or that kind of stuff, right? So they should be more related than contrastive learning, like that. That's the approach that I was thinking of. So then you kind of move it away from ImageNet and you kind of hone it into what spectrograms are. And then after that, you kind of do your classification task.
So
And
you
that's where
take that model, but what? Yeah, but see, that's where, I mean, if you do contrastive with respect, I mean, like, what would be the loss and what would be the goal of that is what I'm still kind of uncertain of.
I'm not obviously not sure about the detail, but I'm thinking any just generic stuff should work, right?
What do you mean by generic stuff?
The usual contrastive learning about that these two are similar and these two are not similar. Just
I see. So just provide.
my idea is that
So
moving away from ImageNet and just moving more to
right. But sticking with your example, so something like this, you take 2 spectrograms I'm just, again, thinking out to get the pipeline in my head. So take your TIM model, but then do the following: that take two spectrograms which are in the same, let's say, which get the same votes distribution, and say that these should be getting closer, or so the loss should be low for two spectrograms with scores that are distribution that's similar, and then provide one with something that's not similar distribution, and say that you should give a high loss for these, and conduct training that way with a bunch of input provided, and then take the output of that step and then go through training on the EEG and Kaggle spectrogram. And that model that you will get as a result is still very big. So through knowledge distillation, turn it into a model. That would be your knowledge distillation. Then, since he lays it out in the pipeline, then the next step is pseudo labeling. So he's assuming that additional data exists. Use this model to label that additional data, the smaller model to label the additional data, then combine the additional data with the original data we have of Kaggle plus EEG spectrogram, and in this stage, just fine-tune the head probably for the 6 classes, and that's the end of the pipeline step. Does that make sense?
That surely does make sense. Like, yeah, that surely can be an approach. But I'm not 100% sure. Do you think the 4 steps that he's mentioned, that is a pipeline, or just those are like the 4 different things that he's tried? Like, I mean, some of the 4 different things that he's tried. I don't know. I'm not 100% sure if that's like a pipeline.
The reason I said pipeline is, if you follow the thread, right? He's saying, I'm excited to achieve single model using all data, both spectrogram and EEG. So the guy next, the question is, do you use 2-stage model? If you don't mind me asking. And the 2-stage model is what I just described, right? Train a model.
This is with lesser votes.
Data, correct. And then use this same models on the next step and train it on data, right? So that, to me, is a 2-stage pipe.
Right.
So then in response is where he says, I use many stages, such as pre-train, knowledge distill, pseudo-label, fine-tune.
Right.
So to me, even if you assume those are just steps, but how do you put the steps together, right, to get to where? And that's where I was saying, what are each of those steps? I mean, each step, technically independent of the problem, I know what it means. But in the case of this problem, what would it mean?
Yeah, I'm not sure how he's kind of,
And how, so that's where I was like, okay, and that's why I articulated the way I did to do, and as you said, maybe pre-train is, like a contrastive learning type of thing. And then take that model.
Like, instead of the 6 votes, there is one consolidated vote for the things, right? Isn't there
yes, there is a consensus vote. There's a consensus vote.
So maybe you could use that on your contrastive learning strategy, because then it becomes like sort of like the binary scenario, right? Instead of using all the 6 votes. So I don't know if that kind of helps you, like train and move away from ImageNet, move towards this the spectrogram stuff. Knowledge distillation, I don't know if that would come further down the pipeline or somewhere there. Yeah, not 100% sure where exactly.
Knowledge distillation is basically just reducing the size of the model, right? I mean,
right, exactly.
Nothing but
using the same
teacher, so
yeah, exactly. Same-ish architecture, but just going to less lower number of parameters.
Correct.
So just making it smaller. And in this
actually, it doesn't have to be the same architecture, right? Like, for example, what I was thinking is ENet B2 is substantially bigger than a ResNet 18D. So you may.
I've never seen it cross architecture. So I may, but
That's
yeah,
interesting.
I'm not 100% sure. I haven't done much work on this.
Okay, I'll check that out as to whether it's always the same architecture with smaller parameters.
Usually I have seen
Interesting.
it, like you said, like it'll be in the ResNet family, but it'll be like a bigger model to a smaller model. And so in this case, yeah, it'll help with what you're basically kind of preventing overfitting, I would imagine, right? You're reducing number of parameters and you're kind of making your model better.
And the reason I put it in that stage or step before pseudo labeling and fine tuning is because if you have a whole bunch of additional data, let us say, right, that you're trying to pseudo label and then you're trying to use that, then by having a large model in those steps, you will be penalized or you'll be hurt. By
Why
having
do
a
you say
quicker model that you can use for the larger data set, which you are going to have after the pseudo labeling, you're better off. So that's why it makes sense to do knowledge distillation where he has it. I mean, again, all this is conjecture, but I'm just trying to,
No.
okay,
Can you
if I were
repeat
to,
that? Why is that a better place to have knowledge distillation?
because once you distill, you have a smaller model, that we agree, right?
Right.
Right. Now, you could, by the time so you could use the smaller model to pseudo label the additional data rather than using the large model,
Right.
right? Now,
Yeah.
that means you would get the pseudo label faster. Now, arguably, you could use a larger model and get more accuracy. So that, I guess, is a trade-off which could go either way. But what
Yeah.
is sure is by the time you get to fine-tuning it,
Right.
you're going to combine the additional data, the pseudo label data, along with the original data, and then fine-tune the model, correct?
Correct.
At that point, you have more data than what you started off with.
Yeah.
So you want the smaller model because then
Yeah.
it will be
At
faster.
that point, yeah. Yeah. Makes sense. Yeah. Yeah. That's all.
So
Yeah.
that's why I'm saying,
If pseudo labeling, there is no necessity for it to be there in between there. That's what yeah, there is, but otherwise, by the time you reach fine tuning,
but
you need
yeah,
smallest
but
model.
if you have knowledge distilled, you could go either way. Do you use the bigger model to pseudo label or the smaller model to do it? It depends on the size of your additional data that you bring in. If it's large, you want a smaller model.
I mean, at that point, you're just inferring, right? So it's really not going to take that much time because you're not.
Oh yeah, that's true. That's true. You're not training. You're just
Yeah.
labeling. Yeah, that is true. Yeah.
So I think that's
That's correct.
all based on whatever great way these guys have managed to pull out a reasonable CV and they're able to trust their CV whether their scores are improving or not improving on whatever they're trying to do with those individual
Yeah,
students.
on the pre-trained part especially, right? I
Yeah,
mean,
even that too. Yeah, in all those pieces.
Yeah,
yeah.
so I was thinking, how does this stage thing works in fine tuning as well? I'm not too sure about fine tuning. Of
Fine
how can
tuning,
we?
I would just say, is you could just use the smaller model and allow it to only tune the head, if you will. That would be my simplistic approach. Again, all of this is a guess, which is why we are discussing it. If you have other ideas, it'd be good to let us
Yeah,
know.
or
But I
the
was thinking,
typical fast AI way of maybe like freezing your differential learning rates and then you're just kind of
right,
tuning it that. Yeah. So yeah, I think it's just
correct.
fine tuning is pretty much that's it. But yeah, again, like the details, what matter for us. But yeah, I mean, God knows what exactly he's doing
Right.
and
But at
how
least,
he's.
I am a little better. The thing that I still struggle with is I have to do a lot of thinking about how to pre-train effectively, like how to set up this contrastive loss thing where, um, that you say, okay, two seizures should be closer than a seizure and a whatever another class, right?
Right.
Because that's what you're aiming.
Correct. So like, for example, there was a segmentation scenario where we were trying to get models trained on different segments of the face, right? Like skin and teeth and all that kind of stuff. And you start off with ImageNet, but then again, there are like all these dogs and cats and all those things which you don't care of. So then I think the way we did it was you use a UNet to kind of just show, okay, this is what the labeled the mask looks like. And you kind of train that to reproduce basically the same mask. So instead of it learning, kind of unlearns whatever the dogs and cat stuff is, and then just kind of starts learning mainly about what faces are, because that's all we care about in that case. Once we did that, then again, you can collect tons of data online of faces. So you do the pseudo labeling of, okay, go ahead and just label all these images that we have, which don't have any masks per se. So you kind of increase your data set size by that. And now you've done, like, these two were kind of done. I don't even know what the order of the pipeline per se was, but then you kind of have more pseudo label data now. You have your,
Hey, Steve joined us.
oh, hey, Steve.
Steve, welcome, buddy. We've been like talking with the first 20 minutes or 30 minutes of our discussion was how come you are in among the medalists in the whatever, the Optiverse. So solve the puzzle for us. Steve, you there? You're still muted. Uh-oh. Unmuted.
Are you talking to me, sir?
Yeah. We spent the first 15, 20 minutes discussing how come you're not among the medalists in the Optiverse thing.
Tell me about it. I just
What
disappeared.
happened? Yeah. What the
I
heck?
was sitting 28th up until the last update, and then my submissions disappeared. I presume it's like I had it. It was like sort of training on the data that was going before, and I'd sort of calculated how many trading days I thought there would be between the start of it and the end of it or whatever. So obviously I miscalculated. Right. Yeah, because it was taking like nearly the whole 9 hours to train initially or whatever. Obviously, it just got too much data and overloaded. So.
Oh man, yeah. I was like hoping you would sneak into the gold, man, in this one.
I was helping that as well. It was a sort of fine line between sneaking into the gold or falling out completely. So.
No, you wouldn't have fallen off. Even Mayank, by the way, made a bronze in the competition, so that's kind of cool.
Oh, so that well done, Mayank. So
yeah.
Next time I need to be more conservative in my estimations, but yeah, it's disappointing because it's just the way you just like sort of disappear altogether. They don't sort of tell you why.
I was like, my God, Steve was like, I was telling Mayank that Steve was so close to potentially getting the gold. I was like, oh man, I hope he sneaks into the gold so I can tell people, hey, I know a gold medalist personally. Anyway, so we were searching for your name and then went to your even entered competitions. It kind of, disappeared. It doesn't even show up among your finished competitions, which is kind of really weird.
Yeah, I know. That's what I found as well. Yeah, because like this morning I went on, I hadn't realized it completed. Yeah, because like obviously it was meant to finish as well. Thursday. Yeah, maybe those extra days is what did me in. Maybe it was like a couple of extra days of data just crashed my model. So
how did you manage to?
Sorry, go ahead, Mike.
So I was thinking, I was referring to how did you manage to add extra data to it? I mean to say, did you got disqualified or something?
Oh no, it wasn't extra data. It's like like they'd started evaluating the models since December, was it? Yeah, so like, so there was new data coming in. Yeah, so there's been 3 months of extra data from you submitted your thing. So like my models were all retraining every time. So yeah, all of the top solutions there, they're they were retraining the models with the new data that's arriving. Yeah, so like my model was trained on the original public leaderboard data, but yeah, like then it would retrain every time that they ran it again. But yeah, like yeah, so I was keeping adding the new data onto the original data. So I was getting more and more data, and like obviously this last update or whatever was just too much data and it couldn't handle it, or it just ran out of time.
Yeah, the thing I was surprised by, Steve, is I thought you had a really clever way whereby you weren't, if I recall, all this is from memory, so I could be wrong, but if I recall, you had this really, in between, you were taking the approach which I tried and fell flat on my face, but of retraining on kind of like every 10 days and stuff. And then you had figured out this even better way of just training or tweaking on the incremental day that's available, that is coming in, right? So I thought that was the best approach because it doesn't take, it just kind of keeps going incrementally rather than kind of having to do all of it in bunches. But is that not the case? So that's why I thought that might, that will kind of keep you safe from running over the 9-hour limit or whatever.
Yeah, so like I had all my models, they were all trained on the initial set of data from the public leaderboard. And then once the models had been submitted for like the private set, yeah, so at that point then I was taking like a sliding window onto the data that was available. But yeah, so it was taking sort of the previous data plus the new data, and then when more new data arrived, it slid the window along a bit. But yeah, I'm not sure. I think yeah. So I'm not sure why the previous updates succeeded and this one didn't, because it should have just been like I think I'd calculate it as I could like get away with something like 60 trading days or something in the past. But
Yeah,
I don't
I
know.
think so. You a little bit in the end. I think so. You were up and running in until the 2 weeks at the end. I think so. We looked at your leaderboard week before last, and it was you were up there. But the
Yeah.
last few updates, the data that flew in, yeah, that got you.
It looks like, yeah, so not sure, not entirely sure like why, yeah, like the last bit did, but I remember calculating
and I think
how many days.
Yeah, and I think I figured out like maybe is it the time change why you joined at 11 rather than because we switched in the US last week.
Oh, right. Oh, sorry if I missed it.
Yeah.
Sorry.
So that's
Yeah, we
probably
have
why I was
been
like,
in
hey man,
discussion for
Steve
more than
hasn't.
an hour.
Oh, yeah, it's the regular time for me.
Okay, yeah. That's why I think I was like, man, he usually is very prompt at posting that, hey, I won't be able to join. So we were surprised you weren't there. And then when you joined now, I was like, wait, this is the same problem again. Like it's the time change that screwed us up.
So do you have daylight saving in Manchester?
Yeah, we do. I'm not sure when it goes. Yeah, what's today? The 23rd. It probably goes tonight, actually. Yeah, we always go on a Saturday night. When did yours go?
Last week.
Oh, right. Yeah, because ours always goes on the solstice or whatever.
Okay.
On the like as close as you get to the 21st. So
yeah. That's
yeah,
why.
ours must go tonight. Yeah, well, sorry I missed things, but yeah, so I haven't made much progress in this competition, like apart from taking this one the leading public notebook or whatever with the 3 models in it. So I've just taken that.
Yeah. So how did you get to 0.30 from 3.1? Because I've been playing with the weights and stuff. Did you use any of the other models in the thing, or what were the tricks that you used?
No, it's just the leading public notebook at the minute gives you a 0.30.
Ah, okay, I see. So because I was playing with this diversity ensemble thing, which gives you 0.31, and I've been changing the weights, and I couldn't get it to go to lower than that. It's like no matter what I change, I mean, I shouldn't say no matter, I just played with 2 or 3 combinations, and those still kept me at 0.3. But in line with what you, Steve, started us off, or at least pointed me to, you're kind of trying to, or you were wondering, just to catch you up on what we have been discussing. You were wondering what Chris Diot has done to get his 0.25 kind of score and stuff last week, or week before last when we were discussing. And one of the things I found, can you see my screen?
Yep.
Okay, so one of the things I found is this post about, and I posted it in Slack too, and I'll anyway post it in our, I posted it in chat, but this guy saying, what is the single best leaderboard model discussion, blah, blah, blah. And here in response, Chris says he's able to achieve 0.25. And then the thing we have been discussing is he says he does this set of things. So what Raquel and I and Mayank have been discussing is what each of these steps potentially could mean. And by the way, if you could do us a favor, and you had pointed last week about additional data that somebody had posted. If you could post a link to that in Slack or in chat, that would be very helpful.
Yeah, so there was some guy, he posted additional data for just the, what do you call it? It was only one of the conditions, the seizure condition it was. Yeah, so he'd published like extra data that was just purely for seizure data. I haven't seen him doing anything else with it since. But through that, somebody else put a link up. Yeah, there's like SparkNet data, it's called, which is where this competition data has come from. It's exactly the same 6 categories for classification. So yeah, like I got that data. I've been trying to use it, but I haven't. The trouble with it is it only gives you like a 10-second window around around the point where they're sort of guessing what the vote is. Yeah, so to use it, you need to sort of squeeze the window of all your models down from 50 seconds down to 10 seconds. Yeah, so I've been playing with that, but I haven't managed to make much progress with it yet. So
because this is where what we, and again, let me catch you up quickly on what at least Raquel suggested, and we kind of converged on our understanding of what these steps seem to mean. And you can chime in on whether you agree or whether there are variations or whether we are totally off on a different planet with what we think these steps mean. So what we, what we discussed and converged on is maybe the pre-training part would be using the network and then training it, take the weights which are pre-trained on ImageNet, but then do some type of contrastive learning, like let's say using the whatever consensus labels to say, make if two spectrograms are seizure, make the model kind of get predict a low loss, whereas if it's a seizure versus one of the other classes, then make sure that the model says it's like, the loss is much higher. Do that for a while, then potentially do, or not potentially, but then do this distillation where you take that large model, and actually the knowledge distillation could happen after the pseudo labeling, but take this additional data that you are pointing to, which is this, the Spark, whatever this, what did you say the additional data name was?
SparkNet, SPARC. Yeah.
SparkNet, Spark as in the Sun guys, Spark CPUs. But so take the model that you have pre-trained and then generate labels if that data doesn't have labels. SparkNet data doesn't have labels, and then do a knowledge distillation where you take the big model and then reduce its size to a smaller model, and then take that smaller model and then potentially on all of the data, which includes the pseudo label data as well as your original data, then just kind of freeze the body and fine tune the head or whatever, and then get that as your final model. Does that make sense, or would you think that there are other explanations or different things that you would do with respect to what he says he has done?
Yeah, no, that sounds reasonable what you just said. Yeah, so I don't know if he's been using this external data or not, but
and that's the thing, right? Because we couldn't figure out. Yeah, we couldn't figure out. Otherwise, if you're not using external data, how pseudo labeling would apply? Can you think of how pseudo labeling could apply without additional data?
There is one notebook in the public set of notebooks that talks about it, where it's using some loop or whatever to, yeah, so it's like a sort of teacher-student thing where it's like training one model, and then it uses that model to sort of predict the outputs and sort of refines. So it's like sort of taking the available labels and like maybe refining them to make them better.
So there is this guy, he says he does this, but this didn't make a whole lot of sense to me.
I don't know, is it that guy? If you just go into the code section a minute, into the public notebooks and search for pseudo label. Yeah.
This guy?
Oh, it was the next one, I think, the label and refine. I don't know what this one.
Yeah.
Yeah, the next one. No one. Yeah, that one. He's got like a picture, I think, a bit down of like a loop thing. Yeah, that. Yeah, I can't say I 100% understood what he was on about. I meant to come back to it, but I haven't.
Okay, but yeah, this makes sense if you have unlabeled examples. That was my key. It would make sense if you have unlabeled examples, but in our case, we have all labeled examples, right?
Yeah.
Oh,
yeah. So he's
this is where he's
yeah.
on low quality. So that means he's using the less than 10, or he's actually using the model that you have trained, which is kind of the teacher model on the second stage, which is greater than 10 volts, and then using that to predict the less than 10 volt case. And then he's combining the low quality labels, which would be the stage 1 labels, with the pseudo labels. I see. Additionally, I applied the same process to 50% of the data with high quality labels. Why would you do that? Because your high quality labels are high quality and you already have the full label. So why would you generate pseudo labels for it? That doesn't make sense.
Yeah, I'm not sure. But
pseudo labels will generate soft labels versus hard labels. So I don't know how far your soft is from your hard on this specific case. So you get a better distribution in that sense when you're kind of retraining.
Correct, but you anyway have a soft distribution. You're not just dependent on the consensus. Consensus is the hard, but in each case you have the soft.
No, but
the actual soft.
Your soft that you're talking of is you're just dividing the ratios, right? That's what you're doing, right? When you say soft.
Correct.
Yeah, so I'm saying you train a model on whatever data, your output is it's like from a softmax, right? You're going to get a probability distribution rather than ones and zeros. So
Yeah.
that's the difference that I'm saying. I don't know how close like your actual labels are versus your pseudo labels for him to do something like this. And maybe that's why he's getting better results, or he's not getting better results. I don't know.
But even if you didn't do the last part, which is don't do this part, you can still do the rest of what he's doing, right?
Yeah, shouldn't make. I think that's the only reason he's trying to do that probably is that's why you see that. I think I'm just guessing because of that 50% of the data that he's using is trying to bridge things together, bring them closer.
Making the soft thing, assuming that there is a difference between the ratios of the votes and the soft distribution that your model is able to generate.
Yeah.
So you're trying to bridge that gap, is what you're saying.
I think. Yeah.
By using 50%. Okay.
Yeah, so this was about the only notebook I'd seen that sort of went into pseudo labeling. Yeah, because I'd seen that Chris Diot said he was doing it. So I'm not sure. Is he doing something different?
Yeah, this is an interesting. Okay, that's good to know.
Yeah, I don't think I've seen this notebook used in any of the ensembles.
What is the score? Does he get a score?
I don't know. Sorry, I'm not sure. Does he submit in this one, or is it just?
He has an imprint.
But if you go back to the public notebooks again a second. If you sort those by public score. Yeah, so that one there at the top, see that's a 0.3, that's the one I've got. Yeah, so that's what everybody's got now for 0.3. So that first model there that he mentions, the ResNet GRU thing, yeah, so I've just been looking at that. It's a good model by itself. Like it gives you like 0.36 by itself. It looks very similar to Chris Diot's original WaveNet one, but just with a different model on it.
In fact, I was using, I don't know whether I've used this one, but I was using this guy and this guy, but this guy, not the K plus E plus KE, but just the KE. I don't know what is the score of the K plus E plus KE. In fact, I was going to try that anyway with the K plus E plus KE because, give me a minute while I hit this guy, the 0.31 guy.
Yeah.
Which is the diversity ensemble. The one good thing about it is, so if you see if you ignore this, because this is just on the Kaggle spectrogram, so ignore that part. If you go to the 0.37, this is interesting because he combines TensorFlow into this. This is a TensorFlow model with a features head starter thing. And the GRU one is, I think, similar to this one because this guy, again, is a 0.36 with a GRU 1D kind of thing. So is this the one that is, I think, a Russian guy because there's a lot of Russian commentary in the comments. Like you can see somewhere down. Yeah.
Yes, that's what I've been using. Yeah, it's all Russian. So yeah.
So that one is 0.36, right? So what I did was I got rid of this guy and then I threw in my own, the two-stage model, which gets 0.34. And I combined those three. And again, I ended up with just 0.31. So that's interesting. What you're pointing out is this guy with three models, of which this is the same, I think. And then this guy, the features plus head starter, that guy is actually pretty incredible because that's this thing, this Min Shing Weng something. But this, what's amazing about this stuff is if you look at the input, the guy has pretty much, which one is that? I think it's this. Yeah, look at it, because I can't look at it, but he has all of these variants, ER, then E, then E, KE plus KE, which is what apparently that 0.3 guy has used, right? Because
Yeah.
that's the K plus E plus KE. But in this particular version, in the diversity ensemble, if I'm not mistaken, sorry, I'm kind of flying around, but I think while he has all of the ability, eventually he just uses, yeah, you see this? He has all of these, K, E, R, which is raw, K is Kaggle, E is EG, K is combination of these two, KR is a combination of K and R, ER is a combination of E and R, KER is all three, K plus E is Kaggle plus EG plus spectrogram plus data augmentation. And in this diversity ensemble, the guy uses just KE or K plus E, I forget. I think he's using KE. And from what you're saying, yeah, if data type is this, right? And then, but did I see that he is just using, yeah, and then he creates the data set depending on the data type. Yeah, you see all these conditionals. Yeah, and here the data type eventually he uses is just KE. But in your 0.30 version, he's using K plus E plus KE rather than just the KE. So that's an interesting delta, because I think these two are the same two models that you see in the other one. I don't know what this third model is. Do you know, Steve, off the top of your head, what that model does? Oh, this is the Andreas-based thing. Okay, this is exactly the 0.41. So it would just be the Kaggle stuff. But then how does he get it to 0.34? Wow. It's interesting. That would be interesting to see how he gets from 0.41, which is Andreas. By the way, that 0.41 is itself an ensemble of 3 different models, but he gets it down to 0.34. Okay, interesting. But it'd be interesting also to see what is the data that he uses, meaning is it just spectrogram or is it a combination?
Yes, I've also tried like create my own ensemble from the various ensemble notebooks, but I wasn't able to get a better score than what they're achieving. So
yeah, interesting.
The other thing I noticed is, yeah, like that one I was talking about, the ResNet GRU one. Yeah, it's all based off Chris Diott's WaveNet notebook, and like in it, you know, like his banana things.
Right.
Where you've got like the 5 electrodes in each banana. In his model, he only takes every second one in the WaveNet one, and that's what's copied there. They've just copied Chris Diott's thing directly. So yeah, it'll take the top electrode and then the middle electrode and the bottom electrode, so it skips them. And I think the reason for that is if you try and use them all with a 50-second window, you run out of memory. The notebook crashes. Yeah, so I've cut it down, as I say, it's a 50-second window, so I've cut it down to the 10-second window and used all of the channels. And by doing that, then it means I can use the SparkNet data, but I haven't finished checking it yet, so I don't know, will it be better or worse because it's narrower windows but more electrodes. Within his thing here, I found, yeah, you can see like he's done like loads of iterations of it.
Yeah.
The current notebook is slightly worse. So if you get his most recent one, he does it in parts. If you look at like this last change, his training ones there as well. Yeah, so there, his last, yeah, if you look at the training one, sorry, the last change in it was to add in, I don't know exactly what he's doing, but like a new frequency channel or something, he said. And it makes things slightly worse. He does it in 3 parts. And so like when you run the training notebook, it writes out each of the 3 parts. And if you actually use part 2 in the inference, you get a 0.36 score, where if you use the part 3 one, you get a 0.38 score. So
Interesting. Good to know. By the way, just FYI too, if you're thinking about trying this, but somebody in the single thing said, you know how we do the how in the 2 stages at least we've implemented, or at least I have implemented, and I think the default is that way too, is to do horizontal flip along with all this. I forget what he calls it, that making it 0 randomly for part of the data. Besides that, he also horizontally flips. And somebody said vertical flipping gave them better results. So I tried that too, but it gives very slightly worse results.
yeah, the only augmentation I've got is the one that does the horizontal and vertical bands on the spectrograms.
But you don't flip?
No.
I did the flip and I was able to get it down to about 0.34 with 10-fold inefficient at P2.
Yeah, unfortunately as well. Yeah, this is my last week. I'm away from next week for 3 weeks. So
yeah, and in fact, one of the other problems I've been facing with is that I am running out of cycles on Colab. So I'm kind of trying to conserve that until I get to the end of the week, and then lining up the things so I can just run it right around that time when I will get another 200 cycles. But I think, unfortunately, I might get that only after the 9th, and I think the 8th is when the competition finishes. I like, bang, that doesn't help me. So I'm being very stingy on what I can run on my Colab right now. Because if you know, many of these things, at least for me, the B2 model, anything efficient in B2, which is what gives me the best score, and the 10 folds. B0 works with V1, but or a V100, but an efficient at B2 requires an A100.
right.
So, and the A100 is like 13 or something per hour, right? 13 units. So I only have like about like maybe 2 or 3 runs left at most. So I'm kind of being very stingy on what I run on there.
Yeah, I went and paid an extra $10 and boosted my time because I'd run out as well.
Okay. Yeah, that maybe I might have to do that because I'm running out cycles.
Yeah, so as I say, like my last throw of the dice here is like that GRU thing, but with adding in the SparkNet data to see if it gives me a better score. If it doesn't, all I was planning on doing was so like that 3 model ensemble. Each of the notebooks it's using is obviously just like they're 5-fold trained.
Right.
So yeah, like I was going to like train on all of the data and just use random seeds and try and replicate like each of the 3 models that he's using in the ensemble, but like try and get a slightly better score for each of those by fully training several models.
By meaning doing different seeds and also increasing the folds?
Well, not using any folds. So yeah, just do a few different random seeds, but each model would be trained on all of the data for however many epochs.
So take that model and kind of retrain it, take the model that they've already trained and train it on the entire data set.
Yep. Yeah, for
But
the
with
same
different
number of
seeds
people.
but with different seeds.
Yes. Yeah, so you get like the diversity by using the different seeds. So each model.
Oh, and when you say, so would you take each of the folds and train them on the entire data set? Is that what you would do with different seeds?
In the past, I haven't actually used the pre-trained fold models. I've just like gone from scratch, but with all of the data. But maybe taking their pre-trained fold ones would be better. I don't know.
Mm-hmm.
But yeah, so like say you got like 5 folds, so like each of the models then is only trained on 80% of the data. And like,
Right.
although you got like the 5 models, they're only 4/5 as good as if you trained on the whole thing. But you know, like from the fold models, you know how many epochs you need roughly. So it's like normally sort of 3 epochs or whatever with their data. So if you train for 3 epochs on all of the data, but just rather than having folds, just do 5 different seeds. So you still end up with 5 models, but each one's trained on all data, just different seeds.
I see. So you don't even start with theirs. You just kind of take the just train it on all the data when starting. Okay.
Yeah.
That's actually a better approach maybe, because you know that the model is good and it's just that you're just kind of, and the only reason to do the folding is because you want to compare the CVs, but you've already gotten that under your belt. So now, in fact, that makes a whole lot of sense to me, because I think one of the things that I've always been somewhat surprised by is Jan LeCun in one of his lectures, and I mentioned it a couple of times, always says that one of the things you must do, even with, any of these balancing, any of the data balancing stuff you do, like, increasing the weights or this or that, he always says that you should take the model that results from all of that and then train it at least once or twice, maybe an epoch or 2 at most, on all of the data, because you want the data, you want the model to be trained on more balanced data, but at the end of the day, the model should become familiar with the way that the actual data distribution is in the underlying data set. So I think that's somewhat similar. While the reason may be somewhat different, but I like what you're suggesting, because it gives you that, you already have proof. The only reason to do the folding is because you want the CV to improve. Once you know that these models are good, then there is, like you say, much better, you don't waste the 20% of the data and you actually are gaining better knowledge. So I think that's a very good approach that you are suggesting.
Yeah, like that's what I've done in the past, because if you take like an ensemble, as I say, like each one of those bits, they're working with fold models, so you can improve each of the models that they're using slightly and sort of push your score slightly, so as you get above people that have just taken the ensemble in its original state.
Very excellent idea. That's an excellent. Actually, you should write up a discussion post on it generically, because I think that's a worthwhile gem of an idea there. You can become a discussion. What do they say? Can you become a discussion grandmaster too? Bummer. So I was thinking you'd get a gold, but it kind of slipped through your fingers this time.
Yes. Back to the drawing board. Start again.
Yeah. But you're racking up this. It's a bummer that they kind of push you out of even a surefire silver as well.
I know, yeah. So.
Yeah, otherwise it would have been a sure thing. You were way up there anyway. Okay. Well, let's see where we get to on this one. So will you be able to join us next week, or are you already on the road?
No, next week I'll be in the middle of the air at this time.
Ah, okay.
So yeah, I'm afraid. yes, I'm away for
the last
the
thing. So
next
good
week.
luck, and post anything that you're able to try and see any good results, and we'll keep plugging away over the next week on these ideas that have come up. So
All right. Well, I hope you have success with
good
it.
day. Thanks for joining. Have a good trip.
Okay.
And
See you in
see you
a
in a
month.
week. Yeah.
All right. Okay. See you later. Bye.